Now let's see what happens when you have damping due to friction. And in particular, consider the equation 9y double prime plus 6y prime plus 37y equals 0 with initial position 4 and initial velocity -2. So in this case, what makes this different compared to the other equation is that we have a y prime term. So this is what's called, once again, damping. And damping due to friction. Because in this case, the damping constant, which is 6, is non-zero. And once again, you can see the details in the notes. I will just kind of just tell you what the solution is. So if you do the auxiliary equation, you get 9r squared plus 6r plus 37 equals 0. And here, in my opinion, it's easier to use the quadratic formula to eventually obtain r is -1/3 plus -2i. And then that gives you the solution. Y of t is a e to the -1/3 t. So t over 3 cosine of 2t. And then b e to the minus t over 3 sine of 2t. And using y of 0, maybe that's for the initial condition, using y of 0 equals 4, that directly gives you a equals 4. And then y prime of 0 is, I believe, -2. That eventually, after some calculation, gives you b equals -1/3. So in the end, y of t here becomes 4 e to the minus t over 3 cosine of 2t, and then -1/3 e to the minus t over 3 sine of 2t. Okay, more interestingly, let's see what happens in this case. So in particular, we start at 4. And what's interesting here is the solution literally damps off. So it becomes smaller and smaller in amplitude and kind of goes to 0, if you want that. And in fact, it makes sense because as t goes to infinity, so note, as t goes to infinity, what happens to the exponential terms? This e to t minus t over 3 goes to 0. And same thing if you multiply it by cosine and sine due to the squeeze theorem. And so y of t eventually goes to 0 as t goes to infinity. And the interpretation of this here is that the motion is sinusoidal, but it damps off. Until it becomes, I mean, not constant, but like constant to the I, until it becomes in the limit. And again, this is due to friction. Due to friction, the motion slows down. And in the end, in the limit, you do reach the equilibrium position.